Hello and welcome to this Bioprocess International Ask the Expert webcast. I'm your host, Leah Rosen, the online editor for Bioprocess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion, and I will ask our speaker your questions from the window. Questions in the window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Michele Bruder from PendoTECH.
Good morning, everybody. Welcome to the webinar, using PendoTECH single-use pressure sensors to precisely measure volume in your bioprocess container. My name is Michele Bruder, and I'm going to take you through this presentation. Thank you for coming. This is our legal disclaimer from our legal department. And the agenda for today, quick introduction to PendoTECH as a company, for those who are not familiar, followed by, in this webinar, you'll be learning about volume measurement in a bioprocess container. We will discuss a pressure mat high-resolution monitor article. And following that, we will discuss the data and summarize volume measurement in a bioprocess container. Lastly, next steps. So to start off, quick company background. PendoTECH has been in business since 2005. We're located in Princeton, New Jersey. Our main offerings include single-use sensors and sensors for limited use. Pressure, temperature, conductivity are some of the big ones. UV vis and turbidity also. We also specialize in process control systems using same sensors. These are geared toward process development and pilot scale operations. And all of this equipment is usually scaled upward from there as well in the GMP environment. A lot of the information can be transmitted using various methods, very versatile. Just to give you a visual, we have the pressure sensor up in the upper right corner that has sanitary flanges, also single use. This is available on hose barb as well, connections. Right below that, temperature single use sensors. This is hose barb connections, and also see the stainless steel probe sticking up in the middle. On the bottom right corner, a turbidity flow cell, single use, that has sanitary flanges. This is the large one, 6.5 centimeter path length. And if you follow over to the left, a UV vis hose barb connection flow cell, also single use. And the last one in the lower left corner, the conductivity single use sensor, also with hose barb connections. Again, all single use and available for inline measurement. Now, one of the reasons why we are doing this webinar, something that's new and exciting and is a very nice addition to this product line. We are taking the pressure sensor, and the next slide we're going to show you, this is the pressure sensor on the left side, and we've taken it and inserted it into a port plate, which is to be welded onto a bioprocess container or bag. This is one of the, as I said, the newest addition, and the final assembly is in the picture on the bottom middle area. The great thing about this is there's, in the actual sensor, it's the same type of sensor, same technology, and the port plate can be, as I said, welded onto a bioprocess container or bag. and then the sensor is inserted. And to ensure that the sensor is securely on the port plate, there is a locking ring that you see in that bottom middle picture that holds it in place. The view from inside the bioprocess container or bag would be the upper right corner picture, and the view from the outside of the bag would be the bottom middle picture. And just to give you an idea of what that looks like on an actual bioprocess container or bag, we're going to go to the next slide, which shows you on the left, it's a zoomed out version of a tote with a bag inside. The tote that was used, you can see there's, if you're looking at the middle picture, you can see the pressure sensor cable coming out of the middle in the bottom. And if you zoom in on the last picture to the right, again, this is a close-up of the actual pressure sensor cable coming out. And the great thing about this, and the reason why this is important, we're using this pressure sensor for flexible bioprocess containers to be able to measure volume. And we're going to get into this a little bit high level, but the neat thing about this is that the pressure sensor would always be in the same position on the bioprocess container. So let me get into how we did and what we did. Here's the data. Basically, what we ended up doing, in order to put our port plate pressure sensor to the test, we conducted our own simulation for this application. One of our custom port plates was welded to the bottom of a 200-liter 2D bio bag. The bag was supported by this tote that you just saw in the back in the slide before, and the tote had slits cut into the side so that we could monitor the actual level of fluid inside. We filled the bag with water that was dyed with food coloring, and that's why it was that color before, so that we were able to measure the actual level. And we used a calibrator. You can see the picture on the right side. One of our R&D engineers was doing the actual measurements. The liquid level measurements were taken at various points, and you can see here, and they were compared to theoretical liquid level calculated from the pressure reading using our high-resolution pressure mat monitors. Now, using the correlation of 0.1 psi equals 2.678 inches of water. That's how the theoretical liquid level was calculated. You can see the results here. All of the pressures measured by our sensor corresponded to very accurate liquid levels. The theoretical liquid level was within 2% of our measured liquid value across all these points. We were very pleased with this results. And the 2% is very well within our sensor accuracy posted on our data sheets and on our website. Going on to the next slide. The pressure mat high resolution monitors that we just spoke of that were used for this particular simulation, as well as in the, they've been around for quite a few years already, and this is something that we want to make sure everybody knows about. They are available with 1 or 2 pressure inputs, as you can see. The one thing that is different about the high resolution monitors versus our regular pressure mat monitors is that this high resolution monitor area has up to 3 decimal places that can be used to see what is reading. This is really important, especially when you're looking at an application such as measuring volume on a flexible bioprocess container. This is major in that there's a major range here, usually between 0 to 6 psi. And the fact that we're able to show a 2% accuracy on our data, this means that you can basically measure all the way down to 0.2 inches theoretically. The PMAT single channel high resolution as well as 2-channel high resolution both can go all the way, have a 0 offset stability plus or minus 0.003 psi, which means that that could be rounded to 0.01 psi, and that allows you to resolve down to that 0.2 inches using the correlation of 0.1 psi equals 2.768 inches of water. The high resolution pressure mat was evaluated pretty well in this article that we have posted on our website. The link is below, and this was determining basically the level of accuracy that the high resolution monitor is able to display. The formula that was listed there was used 0.1 psi down equals 2.768 inches of water, and this is only able to be resolved when you have 3 decimal places. You can resolve it all the way down. The data is shown on the right side, one of the pieces of data. There's several charts in there that display the level of accuracy using the high resolution pressure mat. All of this is based on the Pascal's Principle. So we used the idea that accurately determining the liquid level from a pressure value on Pascal's Principle, which states that the depth of a liquid in a stationary vessel creates a force directly proportional to the height. The equation is listed here. The principle only works for this application because density and acceleration due to gravity are always constant here. Therefore, the pressure reading is directly and solely proportional to the height of the liquid. This is also why the position of the sensor is crucial. It needs to be placed in the same position for all measurements. Basically, this corresponds to the sensor being, or the plate being welded to the same position in every single flexible bioprocess container being used for this application. Moving on. We're very pleased to add the volume measurement for buffer and media containers to our list of applications for PendoTECH single-use pressure sensors. Now, the single-use pressure sensors for flexible bioprocess containers can be used for volume measurement for buffer and media containers as well. Is there any following that last steps? If you would like to request more information on this product, here's my email address and the phone number. Another thing that you can do is you can contact your bioprocess container manufacturer, ask them about this. If you have questions, we're here right now, and more details to come with more conversations. Hopefully you've enjoyed that.
Great. Thanks, Michelle. So we do have some questions coming in. As a reminder, just go ahead and type the questions into the chat window. Um, so the first question is, how does this compare to PendoTECH's traditional inline pressure sensor?
Glad you asked. The great news is that the inline pressure sensor is the same. It's the same sensor technology.
Okay. And what is the temperature sensitivity of the pressure sensor?
The temperature sensitivity of the pressure sensor. That's the same as the regular, the actual regular inline pressure sensors. The temperature. The pressure rating is up to 30 feet tall for a bag. This would correspond to 15 psi for the special pressure sensors for flexible bioprocess containers.
Okay. And can we use the same PMAT as for the pressure measurement?
The short answer is yes. It takes the same connection. It's really recommended for this application that a high resolution pressure mat is used for the, down so that you get down to that third decimal place accuracy. I think I do want to add something to the actual temperature question before. The sensor is not temperature dependent. So just so you know, the operating range is 0 to 40 degrees Celsius for this flexible bioprocess container sensor.
Okay. And is the product available today?
Yes, the product is available today. Of course, with in-house, validations a lot of times are necessary for things like this. So you'd have to test it out. But you should contact your bioprocess container manufacturer because the sensor itself is available as well as the plate that it goes into. But the plate, remember, needs to be welded into a flexible bioprocess container. So it needs to be inserted properly. Okay.
And just clarifying, it's the same material of construction as the other sensors?
The actual sensor, yes. The sensors are available both in polysulfone and polycarbonate.
And can the inline device be used in a similar manner by attaching to a standard bag port located at the bottom of the bag?
So the inline sensor, that's an interesting question because how is this different from other applications previously? The inline sensor is something that has previously been used using a loop. The hesitation there is that the sensor, when it's in line in the loop, is sometimes moves, and then that might have an effect on if it moves, then it's not always the same reading every single time. Whereas this pressure sensor for flexible bioprocess containers is always in the same position every single time. So in that respect, you don't have to worry about whether or not that movement affects that aspect.
Okay.
I think in addition to that, the movement, the reason why I'm concerned about that is because the height could vary randomly as the tube was moved or the sensor, in a slightly different spot, okay? And that might impact, something drawing from the bag. Okay. So the pressure sensor for bioprocess, flexible bioprocess containers is you don't have to worry about that. That aspect is removed from the equation, the movement. Okay.
Okay, and it looks like we just have time for one more question, but there are a good number of questions. So if we don't get to your questions, they are going to be passed on to Michele, and her and her team can follow up with you directly via email or with your contact details after this. So go ahead and continue to ask questions if you have them, but we just won't get to them. So the last question that we'll answer, yes.
Just to clarify that last portion, I just want to make sure that we're clear. The inline sensor cannot be used in the way that this is shown in this presentation. The welded plate for this pressure sensor on flexible bioprocess containers needs to be in that perfect spot on the bottom of the bag or bioprocess container. Okay.
Okay. That works. And so the last question, we'll go ahead and get to it, is, does it also work with a transmitter, DIN rail mounted?
Great question. The answer is yes. It works with our pressure mat transmitters that can be, it has the same connection, so that can be used indeed. Okay.
Okay. Well, thank you very much, Michele.
Thank you. I appreciate the time and opportunity to speak to you all. And I look forward to working with you all.
And thanks again to our audience for joining us. The recorded version of this webcast will be available for on-demand viewing on our website, and as a registered attendee, you'll receive a follow-up email providing you with a direct link. We look forward to having you join us at future Bioprocess International Ask the Expert webcast. Look for those announcements in your inbox. Goodbye.
Bye.